Hello and welcome back to Math with Mrs. Becker. Today in calculus we are going to look at section 8.4 where we study the remaining four trig ratios. Certain functions that involve the sine and cosine, they occur so frequently in applications that they have been given their own special names. The first one is the tangent. Now tangent is they use the letters T-A-N for the tangent. Now the reciprocal of the tangent is called the cotangent, and they use the letter C-O-T to represent the cotangent. The reciprocal of the cosine is called the secant, and they use the letters S-E-C. And the reciprocal of the sine is called the cosecant. Okay, and so again, this is what they look like. We have been studying the sine and cosine. The tangent is the sine over the cosine. The cotangent is the reciprocal of the tangent, so you'll notice the fraction is just flipped, making it the cosine over the sine. The secant is the reciprocal of the cosine. The cosecant is the reciprocal of the sine. So these four functions together with the sine and the cosine make up all six trig functions. The main focus in this section is looking at the tangent. However, we will visit the cotangent, secant, and cosecant in some of the exercises. Now remember, these are properties that we did see back in college trig, and they've kind of sprinkled them throughout this chapter. As we get to the very end of the notes, we will have to use some of these properties and identities to be able to move forward as we are doing antiderivatives, okay? So that's why they're here, just to kind of remind us that when you're dealing with trig, there are a whole lot of rules, okay? So the first thing, let's just go ahead and look at triangles again. Remember, if you have an ordered pair on a terminal side, when you're graphing in standard form, you can always turn this into a right triangle. You do that with the x-axis, always. So here is my 90-degree angle. Theta, the angle you're focused on, is always right next to the origin. Now from the ordered pair, we can figure out two sides of the triangle. The 3 is the x value. So I'm going 3 units to the right, so it's positive. The y, I'm going upwards, so this is the 4. If you use the Pythagorean theorem, 3 squared plus 4 squared equals, I'm doing the math in my head here, c squared. So 3 squared is 9, 4 squared is 16. We're trying to find the hypotenuse. 9 plus 16 is 25. So to cancel the power of 2, the square root of 25 is 5. So now if I want to find all 6 trig ratios, the sine, opposite means you go right across from the angle. So opposite over hypotenuse. So the sine, the opposite is 4. The hypotenuse, the side that is across from the 90, is 5. So the cosecant, that's the reciprocal of the sine, so that's 5 over 4. The cosine of theta, cosine is the adjacent over the hypotenuse, so for us that's 3/5. The secant is the reciprocal of the cosine, so this would be 5/3. The tangent of theta, tangent is opposite over adjacent, so that's 4/3. The cotangent of theta, that's the reciprocal of the tangent, so that is 3/4. Okay, let's look at another one. The next part, they're telling you to place theta in angle A. What you need to remember is that an angle is always across from its side label. So this is side A, so this is angle A. This is side B, so this would be angle B. This is side C, so this would be angle C. A's are always across from one another, B's are always across from one another, as well as C's. So if theta is an angle A, here's theta. If I want to find all 6 trig ratios, the sine is the opposite over the hypotenuse. Oh, I don't have the hypotenuse. It's a question mark. So I'll have to use the Pythagorean theorem first. So 5 squared plus 12 squared equals our hypotenuse squared. 5 squared is 25. 12 squared is 144. 25 plus 144 is 169. If I take the square root of each side, the square root of 169 is 13. Now I'm ready to go. The sine is the opposite over the hypotenuse, so it's 5 over 13. The cosecant of the angle is the reciprocal of the sine, so 13 over 5. The cosine of theta, the cosine, here's theta, cosine is the adjacent over the hypotenuse, so that would be 12 over 13. The secant of theta is the reciprocal of the cosine, so that's 13 over 12. The tangent of theta, tangent is opposite over adjacent, so that's 5 over 12. The cotangent of theta is the adjacent over the opposite. So that is the intro to 8.4. They went ahead and just reviewed that there's actually 6 different trig ratios. We looked at 2 different ways you could have right triangles. One is within the coordinate plane. Again, when it's in the coordinate plane, one side of the triangle must be the x-axis. Theta is always next to the origin. The other one is just if you have a straight up right triangle. Okay, let's go ahead and look at a couple story problems. So if I am looking here, the angle of elevation from an observer to the top of a building is 29 degrees. So we have a little dude, and he's looking up at a high building. Now, when you have an angle of elevation, that angle has to go from the horizontal. So here's the horizontal. It's called elevation because you're looking upwards. There's your 90-degree angle. The angle of elevation from the observer to the top of the building, this is 29 degrees from the horizontal looking up at the building. If the observer, so right here, is 100 meters from the base. Okay, so I'm going to draw this a little bit better. So here's my 90. This is 29. The observer is 100 meters. How high is the building? So across from 29, that is the opposite. Across from 90 is the hypotenuse. The third side is the adjacent. When I want to solve for x, I cannot use the hypotenuse because I don't have anything at that location. I do not have a number. I do not have a variable. So I have to use the trig ratio that is opposite and adjacent. That is the tangent. The tangent of the angle, so 29. Tangent is opposite, which is x, over adjacent, which is 100. To solve for x, I have to multiply both sides by 100. So x, I'm going to make sure that my calculator is in degree mode. Remember to do your calculator, I want it in degrees because we're looking at a 29-degree angle. So I would have 100 times the tangent of 29. That building would be 55.4 meters. The reason why I know it's meters is because the one measurement for length that they gave us was that the observer was 100 meters from the building. Okay, here's another one. We have a tree, and the tree is casting a 60-foot shadow. Okay, the angle of elevation, so from the horizontal looking up to the top of the tree, is 53 degrees. How tall is the tree? There is our right triangle. Across from the angle, we are looking for the opposite. Across from 90 is the hypotenuse. There are no variables or values there, so you cannot use the hypotenuse. The third side is the adjacent. So again, opposite and adjacent, that's the tangent. The tangent of the angle, which this time is 53 degrees. Tangent is opposite over adjacent. To get rid of the 60, because it's on the bottom, I go ahead and multiply both sides. So if I take 60 times the tangent of 53, that tree, and it's going to be in feet because the shadow is 60 feet, that tree, if I round it to the 10th, is 79.6 feet. Okay, so 2 examples of applications where you would need the tangent. Now let's go on to derivatives. Remember, the derivative of a sine is a cosine. The derivative of a cosine is a negative sign. Now, the derivative of tangent is a secant squared of x. If it is just an x, this is what you would get. If you have anything more than just an x, you would have the secant squared of whatever this is times the derivative of that. So let's go ahead and look. The derivative of a tangent is a secant squared. You keep this the same, so t cubed plus 1. Now you multiply by the derivative of the inside, which would be 3t squared. So just to kind of clean it up a little bit so the problem doesn't look so lengthy, you would have 3t squared times the secant squared of t cubed plus 1. If you left it here, you're fine because that's all the pieces. Okay, the next one. If I have a tangent cubed of t, that is the same thing as tangent of t cubed. So general power, bring the 3 out front, keep the tangent of t the same, reduce the exponent by 1, so now it's a 2, multiply by the derivative of the inside. Derivative of a tangent is a secant squared. So it would look like this. 3, remember one way to show that exponent is to put it in between the trig ratio and the variable. So 3 times the tangent squared of t times the secant squared of t. That's the derivative. Now here's where it gets a little bit tricky. Notice we have derivatives for sine, cosine, tangent. We don't have a derivative for the cosecant, but we know the cosecant is 1 over the sine. The cosecant is the reciprocal of the sine. So if you end up with something like this, you have to do the quotient rule, even though the top is just a number. So f of x is 1. G of x is the sine of t. When you are doing the quotient rule, you keep the bottom the same, sine of t, times the derivative of the top. The derivative of 1 is 0. Minus, keep the top the same, 1, times the derivative of the bottom. The derivative of sine is a cosine. Well, this ends up being a 0 because anything times 0 is 0. Negative 1 times cosine of t is negative cosine of t. Now you take the bottom and you square it. So this would be sine squared of t. If you get it to here, you're great. You did the calculus. Best answer would be negative cosine of t. Sine squared of t means you have the sine of t twice. So I'd have a negative cosine over sine is cotangent of t. 1 over a sine is a cosecant of t. So negative cosine of t over sine squared of t, using trigonometry, we would have a negative cotangent of t times a cosecant of t. This would be the best answer, but if you can get it to here, you're fine because this is the calculus component. This would be combining calc and trig. Okay, next one, cotangent. We do not have a derivative for a cotangent, but we know the cotangent is the cosine over the sine because it's the reciprocal of the tangent, and tangent is sine over cosine. So again, I have to do the quotient rule. F of x is the top, so it's cosine of 3t. G of x is always the bottom, so it's sine of 3t. Quotient rule, leave the bottom the same, sine of 3t, times the derivative of the top. The derivative of a cosine is a negative sine. Keep the 3t times the derivative of 3t, which is 3, minus the second chunk. Keep the top the same. So cosine of 3t times the derivative of the bottom. The derivative of a sine is a cosine. Keep the 3t times the derivative of 3t is 3. So now when I simplify this, positive times a negative times a positive, it's negative. 3 out front. Sine of 3t times sine of 3t is sine squared of 3t. Minus sine. There's a 3 out front. Cosine of 3t times cosine of 3t. I have 2 of them. Cosine squared of 3t. So there's the top. Bottom, you take the bottom and you square it. So sine squared of 3t. Now I cannot simplify this. If I just had this, I could cross those off, but I do not have any sine squared of 3t's here, so this would be your final answer. Next one, I can take this 5 out front. So I would have 5 times the derivative of the tangent of 2x plus 1. 5 goes out front. The derivative of a tangent is a secant squared. Keep 2x plus 1 the same. Now multiply by the derivative of inside, which is a 2. So we'd have 10 times the secant squared of 2x plus 1. Done. Next one. If you have a square root of a tangent of t, that's the same thing as tangent of t to the 1/2 power. So this is general power rule. Bring the 1/2 out front, keep the tangent of t the same, reduce the exponent by 1 times the derivative of a tangent, well, that's secant squared. So now when I write my final answer, I know I have a 2 on the bottom because it's 1 over 2. This would also go on the bottom. It's a negative exponent, so I'd have a square root of a tangent of t on the bottom. This has a positive exponent, so secant squared of t would go on the top. Let's look at a few more derivatives. If you have a natural log, remember natural log means 1 over whatever you have here. So 1 over the tangent of t times the derivative of whatever's on the bottom. The derivative of a tangent is a secant squared of t. When you multiply fractions, it's top times top, bottom times bottom. This ends up being secant squared of t over tangent of t. Done. Next one, this is a product rule because you're multiplying two functions together that both contain a variable. When you're doing the product rule, the first thing, and in this case it's e to the 3x, gets multiplied by the second term, which is a tangent of 2x. When you are doing the product rule, you keep the first term the same, e to the 3x, times the derivative of the second. So this would be the secant squared of 2x times the derivative of 2x, which is 2, plus keep g of x the same, tangent of 2x times the derivative of e to the 3x. Because this is more than an x, the derivative of 3x is 3. Now you look and see what they have in common. Both of these groups have e to the 3x. So e to the 3x comes out front. That leaves me with 2 times the secant squared of 2x plus 3 times the tangent of 2x. Product rule. Okay, here's another one where we do not have a derivative of a secant. So if you know that the secant is the reciprocal of the cosine, you can write it as a fraction. And even though the top is just a number, in order to find the derivative of this, you do need to use the quotient rule. F of x is the top, so it's just a 1. G of x is the bottom, so it's a cosine of x. Quotient rule, keep g of x the same times the derivative of the top. The derivative of 1 is 0, minus keep the top the same, 1, times the derivative of the bottom. The derivative of a cosine is a negative sine of x. Well, cosine of x times 0 is 0. Negative times a negative is going to make this positive, so I would have 1 sine of x over the bottom squared. Cosine squared of x. If you got to here, you did the calculus. The best answer here would be sine of x over cosine squared means you have 2 of them. So the sine would go over 1 and a 1 would go over the other. Sine over cosine is a tangent. 1 over cosine is a secant. This is the best answer, but again, if you can get it to here, you did the calc right. Last derivative, then we'll look at some antiderivatives. So this again has to be the quotient rule because I have a fraction. F of x is tangent of 2t. G of x is cosine of t. You keep the bottom the same, cosine of t, times the derivative of the top. The derivative of a tangent is a secant squared of 2t times the derivative of 2t, which is 2, minus the second group. Keep the top the same, tangent of 2t times the derivative of the bottom. The derivative of a cosine is a negative sine of t. So on the top, I have, just to make it look a little bit nicer, 2 times a cosine of t times a secant squared of 2t. Now, if I multiply these two together, positive times a negative is going to be a negative. If you minus that negative, it's going to be a plus. Tangent of 2t times the sine of t, all over the bottom squared. Cosine squared of t. Those are derivatives. Quotient rule, product rule, natural logs, general power, all those different things. Now, when you're doing antiderivatives, remember an antiderivative for a cosine is a sine. The The antiderivative of a sine is a negative cosine. The antiderivative for a secant squared is a tangent. So here, this is the same thing as secant squared of 1/2 x dx. The antiderivative of a secant squared is a tangent. I keep the 1/2 x. Now I find the derivative of this and divide it. So the derivative of 1/2 x is 1/2. If you divide by 1/2, that's the same as multiplying by the reciprocal. So my antiderivative is 2 times the tangent of 1/2 x plus c. Next one, here's the one where we don't know the antiderivative for tangent squared. Okay, that's not going to help. If I was doing a derivative, I could use general power rule. That doesn't work with antiderivative. So we're kind of stuck. So this is where these product or these different identity, these rules that are on the first page will help out. We need to know what is tangent squared of x really. Well, here is a tangent squared of x. If I want that by itself, I could minus 1. So tangent squared of x equals secant squared of x minus 1. Because of this property right here, it's called a Pythagorean identity. I could rearrange this and get tangent squared of x simplified, or I could just change it to secant squared of x minus 1. So that's what we have to do. So secant squared of x minus 1 dx. I have more than one term. So I need the antiderivative of the secant squared of x dx minus the antiderivative of 1. There are no x's, so I'm putting x to the power of 0 dx. The antiderivative of a secant squared is a tangent minus, if I add 1, I would have 1 divided by 1, so it's 1x plus c. Next one, antiderivative of a secant squared is a tangent. Keep the 2x plus 1 the same. Find the derivative of the inside, which is a 2, and you divide it out front, which is the same as multiplying by the reciprocal. So it's 1/2 tangent of 2x plus 1 plus c. Last one. Now here, again, this is yucky. But what you have to realize is that 1 over the cosine, that equals the secant. So rather than keeping it like this, 1 over the cosine squared of 2x, the reciprocal of a cosine squared would be the secant squared. So that's what we'd actually have. These two things are the same because a secant squared would be a reciprocal of a cosine squared. The antiderivative of a secant is a tangent. Keep the 2x. The derivative of 2x is 2, so if I divide by 2, that's the same as multiplying by 1/2 plus c. That is 8.4. So there are some suggested book assignments if you're going for the extra credit on the test. Otherwise, your assignment today is a one-sided worksheet practicing all the things that we covered in 8.4. I hope you had a great day, and I will talk to you soon.